Hello dear children. In last video we have seen what are the physical properties of metals and non-metals. So let us first revise that physical properties of metals and non-metals both. Then we will go for the next property, that is your chemical properties. So what are the physical properties of metals and non-metals? First, they are hard in nature. They are having lustrous, or we can say the shiny appearance. Next is they are sonorous in nature. This all I am talking about the metals. And next thing is they are the good conductors of heat and your electricity. So these points you can mention in the physical properties of your metals. And what about the non-metals? They are not very hard, they are brittle, we can write. They are non-sonorous, they are non-lustrous, they are poor conductor of heat and electricity. So these points you can mention in your physical properties. Now next properties we are going to see, that is what are the chemical properties of your metals and your non-metals. So first we will see about your reactions of metals with your oxygen. You can take any of the metal. See, you're familiar with the iron metal the most. Why? See, because you are having windows, you are having your gates, or you are having many of the materials which are mostly made up of your iron. So what is the symbol for that iron? Now onwards you have to remember the name as well as the symbol of that particular element also. Okay, so when I am talking about the iron material, so your windows or your gates are made up of your iron material, and when they are coming in contact with the moist air or the oxygen which is present in air, they are forming the ferric oxide. So here I have given you the reaction. Fe means your iron plus oxygen, that is your O2, plus water, that is your H2O. So what product you will get? Fe2O3, that is ferric oxide, plus hydrogen gas will get E4. This reactions answer you have to write in your textbook itself. They have given one paragraph in your textbook. You can refer that and you have to write this answer in your textbook. Okay. And second thing is, we have performed in grade 7. We have not performed, but you have heard about this magnesium ribbon. So what is the magnesium ribbon? What we have to do is, we have to take that magnesium ribbon. Ribbon means what? Magnesium metal strip we have to take, and we have to heat that on the burner. Okay, when you will heat that magnesium ribbon, what you will get? After some time you will collect white powder ash or white powdered compound. Okay, so what I have to tell you from this, when you are burning with air, that is when you are burning with the burner, with the help of the burner, we are providing the oxygen gas. That is, what is the reaction? Magnesium, that is Mg, plus your oxygen, that is O2, will give you the formation of MgO, that is your magnesium oxide. So these two reactions you have to remember. Now what we are going to do, we are going to see the reaction of metals with oxygen with the help of one activity. Okay, so when we will see this activity, you have to need some litmus paper also. I have already shown you how the litmus paper looks. Okay, we are having the two types of litmus paper, red litmus paper and blue litmus paper also. So let's see the activity which is based on this. We are having the activity when we are talking about, see, we have seen now the your Fe metal, that is iron metal, and your magnesium metal also. But one more metal we are having when it is coming in contact with your air, that is your copper metal. So what about then copper metal? See, when you are having the iron metal, it is getting coming in contact with moisture, it is getting rusting. Rusting means what? Corrosion will take place, and some brownish color or layer will get deposited over that material. And what about magnesium? Magnesium, when it is coming in contact with oxygen, it is producing the white color compound or ash we are getting, which is in white color. Then what about the copper metal? When copper metal is coming in contact with your moist air for a long time, it acquires a green coating. Likewise, iron is acquiring brownish color deposition of layer, and here in case of copper we are having the greenish coating, okay, or green coating, and that green material, it is due to the presence of your copper hydroxide, that is your CuOH twice, and copper carbonate, that is CuCO3. Cu is a symbol for your copper. This also you have to remember. OH twice, that is your hydroxide group, and CO3 means your carbonate group. So green color layer deposition, it is due to which two compounds? Copper hydroxide and copper carbonate. This also you have to remember. And what is the reaction will take place then? First you are having copper material, so copper plus water plus carbon dioxide plus O2, that is your moist air, that is your water, carbon dioxide and oxygen will contain or will form your moist air, and when this moist air is coming in contact with your copper, you will get the formation of copper hydroxide plus copper carbonate. Okay, let us see now the activity 4.3. Now what you have to do is, you have to check the rust which is formed as a result of the reaction between the iron. Okay, so let me tell you what you have to do. You will need iron rust. Okay, we are having the window already, they are rusted many of the times, and already it is rusting. Yeah, so you have to collect that rust, some of the rust, then collect the spoonful of the rust and dissolve it in a very dilute amount of the water. So you have to take suppose you are taking 1 teaspoon of the your rust, then you have to take same amount of the water and just you have to dissolve that rust properly into that water. Then you will find after some time that after dissolving, let it settle down, the suspended particles are or the iron particles or the rusted particles are suspended in the water. So you have to, what you have to do, you have to again shake that suspension well. Once you will shake that suspension well, because that rust will not get dissolved into the water, okay, that suspended particles will move in the water itself. Now what you have to check is, you have to check the solution which you have created with the help of red and the blue litmus paper. Now what do you observe is that solution will be acidic or the basic, that you have to note down. So according to us, when we are preparing that solution, what you will get, you will check first with the help of red litmus paper. Red litmus paper will show you the color change, that is red litmus paper turns into the blue litmus paper. And what about then blue litmus paper? Blue litmus paper will show which does not show any color change. Okay, so from this we can say that, here I have in the first slide only I have written here, see, when we are having the reaction of metals with the oxygen, we are getting the red litmus paper, it changing into the blue one. And what is our conclusion from this activity? That is, all the oxides of the metal, oxides means what? Those who are coming in contact with oxygen, in which oxygen is present. So those oxides of the metals are basic in nature. Why basic in nature? Because already we have studied in grade 7 the litmus paper change. When red litmus paper turns blue, it is your basic character or basic solution, and when blue turns red, that is your acidic solution. So here we are getting all the metal oxides are basic in nature. So I hope you have understood this activity, and please write that answer in your textbook itself. Now see, here they have shown you how you have to do as the rust suspension is there, red litmus paper, how we are checking the solution. Okay, so likewise you have to perform. Next activity we have to do, that is you have to take a small amount of powdered sulfur in a deflagrating spoon and heat it. So deflagrating spoon, if it is not available, what you have to do is, you have to take any metal cap, bottle cap, and you have to wrap the metallic wire around it and you have to shape as shown in the figure. See here, I will show you how you have to make. You can take any metal cap of your medicine bottle or your any cold drink bottles, and you have to attach some metallic wire to it. So likewise, deflagrating spoon you have to make it with the help of one lid. Now as soon as, what you have to do is, once you will get the shape, or once you will form that assembly with the help of metallic cap, what you have to do, you have to heat that sulfur. Okay, so as soon as sulfur starts burning, you have to introduce that spoon into the glass jar or the glass tumbler. You can take, now at home you are not having the glass tumbler, so what you will take, you will take a glass, and into that glass, first of all you have to burn that sulfur powder. You have to take that sulfur powder into that your particular assembly that we have made, deflagrating spoon, that lid we have taken of the medicine bottle. So just put that small amount of sulfur powder into it, heat that sulfur powder. Once it is getting vaporizing, directly put it into the glass tumbler and cover it with the help of the lid, so that the gas which is produced or the vapors which are coming out of that lid of the sulfur, they will not get removed out after some time. Now add small amount of water into the tumbler and quickly replace the lid. What you have to do is, first of all, what we have taken that lid, we have deflagrating spoon we have prepared. Into that we have put sulfur powder. Then we have wrapped a metallic wire so that we can heat with the help of that metallic wire directly on the burner. Once the sulfur starts burning, that is, it is producing the vapors, what we have to do, we have to put that spoon into the glass tumbler and immediately we have to cover that lid. After some time, we have to add some little amount of water into it, and we have to change the lid also. Put another one lid. Now what you have to do is, you have to shake that tumbler well. Then you have to check the solution now with the help of red and the blue litmus paper also. See here, they have shown you how the assembly you have to do is. So what will be your observation then? You are having this sulfur, and as you are burning that sulfur powder, so who is coming in contact when you are burning? That means what? We are providing the oxygen. So which two products are getting involved? Sulfur and your oxygen. So when sulfur dioxide is dissolved in water, sulfurous acid is formed. And what will be the reaction? Sulfur dioxide, that is SO2, plus water, that is H2O. Sulfurous acid means what? H2SO3. And what will be the color change? You will observe in your litmus papers. Sulfurous acid turns blue, litmus red, because we are forming the acid. So which litmus paper will show you the change? Blue litmus paper will change into the red one. And what will our last conclusion is, oxides of non-metals are acidic in nature. And what is our first observation from first reaction? Oxides of metals are basic in nature and oxides of non-metals are acidic in nature. So next activity, that is activity 4.5. Now here I have already told you in the last video, that is potassium and the sodium metal, these are the very soft metal and they can be easily cut with the help of the knife. But we have to handle with care with these both of this metal, because they are easily catching fire when they are coming in contact with water. So while performing this activity, you should take precautions. What you have to do is, you have to take 250 ml of beaker, fill half of it with the help of water. Now you have to cut first of all small piece of the sodium metal, okay, like of the rice or wheat gram we can have. Dry it using the filter paper. You have to press with the help of that filter paper, so that the moistness of the sodium metal will get removed, because we are dipping that sodium metal into kerosene. Now dry it using the filter paper, wrap it in the small piece of the cotton, put the sodium piece of the metal wrapped in the cotton directly into the beaker, which is filled with the water. Now what you have to do is, what you will observe, when the reaction stops, touch the beaker. What do you feel? Has the beaker becomes hot? test the solution with the red as well as blue litmus paper. Is that solution is acidic or the basic? Now when you will put, what you have to do, you are taking the 250 ml of beaker. In that you have half filled with the water, and you are cutting the small piece of sodium metal. Then you are drying it with the help of filter paper. Then you are putting that small sodium metal into the cotton, and you are wrapping with the correctly with the help of the cotton, and directly you are putting into the your beaker. What you will observe, after some time it will get hot. The outer surface of the beaker will become hot. Why? Because sodium metals is having the various vigorous reaction with the metal. So here I have given you the conclusion. Sodium, potassium and calcium react with always cold water. Magnesium metal reacts slowly with hot water to form slightly soluble magnesium hydroxide. Aluminium, zinc and iron react with steam. Lead, copper, silver, gold do not react with water. And calcium and magnesium float on the water as bubbles of the hydrogen stick to their surfaces. So here what litmus paper color change you will show, as sodium and this your sodium is a metal, so it will react with the acid. So it will we have seen already the metallic oxides or oxides of the metals are basic in nature. So which color which litmus paper color will show you the change? A red litmus paper will change into the blue one. So that is your observation. Next, activity 4.6. so here what you have to do is, while performing this activity also you have to take very precautions, because we are handling the acid as well as the bases. So take samples of the metals and the non-metals listed in table 4.5 in separate test tubes. Label them as A, B, C, D, E and F, and add 5 ml of dilute hydrochloric acid one by one. And in another solution, while performing this activity, we have to add simultaneously the dilute sulfuric acid also. So here they have, I have not given here the table, you can refer the table in the textbook. They have given you iron, magnesium ribbon, your coal. You can take any of the material which is easily available, and you have to check that solutions or that metals and non-metals both, first with the help of hydrochloric acid and secondly with the help of sulfuric acid. So what will be your conclusion then, when we are having for the metals, when I am talking about for the calcium, sodium, potassium or your then what you will have, generally metals react with acids and releases hydrogen gas with a pop sound. See, I will tell you, when you are, suppose you have taken the iron, okay, rust we have taken. So what you will do, you will dilute it with the hydrochloric acid. Okay, 1 teaspoon of rust you will take, you will dissolve it into the hydrochloric acid, and you will take burning matchstick. Okay, you have to burn that matchstick, and just you have to hold near the mouth of the test tube once you will mix the solution. Sometimes you will heard a pop sound. Okay, some amount of sound you will heard, so that we are calling it as a pop sound. But this pop sound we are hearing in case of only the metals. So here why? Because they are releasing the hydrogen gas, so because of that you are having the pop sound effect. The presence of hydrogen gas is confirmed by bringing a burning matchstick or candle near the gas. If you are fearing of the burning the matchstick, you can take candle also. You can take the candle near the mouth of the test tube, and you can observe the pop sound. So that means that hydrogen gas is evolved in that particular reaction. And when you are having the copper, it does not react with hydrochloric acid, but it reacts with the sulfuric acid. And non-metals, they are not reacting with acids at all. Now next reaction, next activity, that is you have to now prepare the solution of the sodium hydroxide. So sodium hydroxide, it is not available in powder form. We are having the pellets of the sodium hydroxide. So you have to take 3-4 pellets. Pellets means what? A small likewise tablet shape we are having that pellets. So that pellets you have to take and you have to dissolve it into the 5 ml of water. Then drop a piece of aluminium foil into it. Bring a burning matchstick near the mouth of the test tube and observe carefully. Okay, so here what you have done, 3 or 4 pellets of your sodium hydroxide, 5 ml of water, and what you have to do, again you have to bring a burning matchstick or candle and you have to observe. So what will be your observation? This reaction, it is of the bases. We have finished with reaction of acids. So when the reaction of metals with bases releases hydrogen gas, many of the metals react with sodium hydroxide to produce hydrogen gas, and non-metals, they are when they are reacting with bases, they are very complex in nature. So here we have finished with the chemical reactions of the metals as well as non-metals. I hope you have understood this well, and if you have understood, please copy the activities answer in your textbook itself. Okay, next part we will see in the next video. Thank you, dear children.